In mass communication, we are going to be talking about and introducing relationships between mass and volume. So we should have already known how to use these terms. We talked about those before. We should use appropriate units of measurement, because units, as we said yesterday, are very important. We're going to talk about measuring the mass of an object, and we're going to talk about measuring volume of objects in two separate ways, by calculation and water displacement. Moving forward, volume is the amount of space an object occupies. So the amount it can be measured in a couple different ways. For a regular shaped object, which those are what you guys talk about in geometry, like a sphere, a rectangular prism, a cube, etc. You can calculate the volume by its dimensions, like by measuring its length and stuff. So, and we can also measure by water displacement. I think we'll talk about that in a little bit later, but displacing means to move somewhere else, to displace, to change the place. So I'll give you guys a second to copy this down. Volume by calculation that's what you talked about in geo class. So for instance, the volume of a sphere, all you have to do is measure the radius, and the volume is 4/3 pi r cubed. For a cylinder, the volume is pi r squared times the height. For a rectangular prism, it's just the length times the width times the height. You guys don't have to copy these down. It's just a quick review for you guys. So that's how to calculate the volume by dimensions. You measure the dimensions and you can find the volume. Volume by displacement, interesting. No, do not copy this down. I'm just going to show you guys a cool little video thingy. Yep, exactly, Stephanie. So Archimedes is a famous scientist, and he found out that if he fills up a bathtub with water and then gets in the bathtub, some of it spills out. You guys are very familiar with this, I hope. You guys bathe? Good. Okay. So, I have a fun little YouTube video that I'm going to show you guys. It's pretty quick. It'll load up in a second. So, Archimedes and the story of the Golden Crown. So, pause it. So, the story goes, is Archimedes was the king's head scientist, or advisor. And the king commissioned a goldsmith to make a crown for the king. And the king wanted nothing but the best, so the king wanted gold. He was looking at the crown one day, and he's like, this looks a little different from the other gold I have. I wonder if it's all gold. Archimedes over here, this guy, tried to figure out a way he could test it out. So he was thinking that if he figured out how much gold was in the same mass as the king's, it should occupy the same volume. So he had an equivalent amount of gold as the crown. He wanted to compare it. If they had the same volume, then they'd both be gold. If they didn't, well, that means the goldsmith cheated the king. So if it was partly silver, it would be lighter if they had the same volume. So Archimedes was trying to figure out, how could I measure the volume of a crown, an irregular shaped object, without melting it down, of course, and ruining the crown. So he was thinking about this, and he said, well, you know, I'll think about this in the bathtub. He got in, and the water overflowed. And that is when he came up with the concept of water displacement. So, he put the crown into water, and that's also the story of how he ran through the streets screaming "Eureka!" naked. That was the legend. I don't know how true that is. So he was so happy, he went right to the king and told him, and found out that the goldsmith had cheated the king. And you guys know what happens when somebody cheated the king way back when? Yes, they removed their head. Which, from what I understand, I haven't taken biology in a while, but people can't live without a head, correct? Correct. So that's the story of Archimedes and the king and the golden crown. That's it. That's it for that. So that's really where we came up with water displacement. So, how to read a graduated cylinder. We'll talk about. Yes, this is important. You guys do want to write this down. The meniscus is the curve that water forms when it's in a container. So you guys can see there's a close-up picture here of a meniscus right there. So you guys see how it goes up in the sides? It actually does this in most containers. It's more prevalent in a graduated cylinder because we can see it because it's thinner. Antonio, can you just keep your head up first? Sorry. Yeah. Okay. So this happens because water molecules actually stick to each other and other things. You know this because when you put your hand in a dish of water, what happens to your hand when you pull it out? It's wet. Water sticks to your hands. So, and it also sticks to the side of the glass container. So that's what causes a meniscus. So how we read the volume is at the bottom of the meniscus. You guys are going to want to take this down just to remember it. So we read this from where the bottom of that meniscus, the lowest point, that's where we measure it from. So this here volume should be 20 milliliters because that meniscus here hits the bottom of that 20 milliliters right there. Oops, sorry. So, volume by displacement, this is important, you should write this down. So, to calculate the volume by water displacement, if we have a graduated cylinder with some water in it, and we add an object to it, like we have, like I said over here, the level of the water will rise up, similar to Archimedes in his bathtub. When he put himself in the bathtub, the water level rose and overflowed. So we can actually calculate the volume of this object right here by the difference in the volume from when it ended up compared to where it started. So that would be the volume of the object is equal to the final volume subtracted from the initial volume. Make sense? Okay. So that's what we're going to be doing. So I want you guys right now to calculate the volume of the fish. I want you to write down your calculations too and show me how you would calculate that. Okay? So let's do that.